Hello, in this lecture we will find the area of the green circle. In the drawing we have triangle ABC, and inside the triangle we have a circle, a green circle that inscribed inside triangle ABC. We know that side AB of triangle ABC equals to 13 units, side BC equals to 15 units, and side AC of triangle ABC equals to 14 units, and we want to find out the area of the green circle. Okay, so we will start with the first method to find the area of the green circle. First of all, we will find the area of triangle ABC in the first method. So it is actually the first method to find the area of triangle ABC. Okay, so first of all we will define the theorem of semi-perimeter of a triangle. The semi-perimeter of a triangle is actually the perimeter of the triangle divided by 2. Okay, so actually the semi-perimeter of triangle ABC, this triangle, if side AB equals to A, and we know that A equals to 13 units, and the side BC is defined as B, and B equals to 15 units, and side AC of triangle ABC is C, and C equals to 14 units, then the semi-perimeter of triangle ABC equals to A plus B plus C over 2. Okay, so semi-perimeter of triangle ABC is the perimeter of triangle ABC, that is A plus B plus C. The sum of the sides of triangle ABC is A plus B plus C over 2. Okay, so actually A equals to 13 units, B equals to 15 units, and side side the AC, that is C, equals to 14 units, and we divide it by 2. So actually the semi-perimeter of triangle ABC is the perimeter of triangle ABC, that is A plus B plus C, the sum of its sides, divided by 2 is the semi-perimeter of triangle ABC, and 13 plus 15 is 28, and 28 plus 14 is 42, and 42 over 2 is 21. So the semi-perimeter of triangle ABC equals to 21 units. We will define the semi-perimeter by the letter S. S is the abbreviation of semi-perimeter, so S equals to 21 units. That is to say, the semi-perimeter of triangle ABC equals to 21 units. Okay, the semi-perimeter of triangle ABC equals to 21 units. Okay, it is the perimeter of triangle ABC, that is A plus B plus C over 2. That is the definition of the semi-perimeter of triangle, and especially in triangle ABC, it is A plus B plus C, that is 42 units, over 2 is 21 units. So the semi-perimeter of triangle ABC equals to 21 units. Then we have the formula for the area of triangle ABC. It is a special formula. The area of triangle ABC, A is the abbreviation for area, so the area of triangle ABC equals to the root of S, when S is the semi-perimeter of triangle ABC, S times S minus A. A is the size of side AB of triangle ABC, that is 13 units. S times S minus A times S minus B. B is the size of side BC of triangle ABC, times S minus C. When C is size AC, is the size of AC, that equals to C, that equals to 14 units. Okay, so the area of triangle ABC is equal to the root of S times S minus A times S minus B times S minus C. And we have already found out that S equals to 21 units. And we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. So the only thing that is left in order to find out the area of triangle ABC is to substitute S by 21 units, substitute A by 13 units, substitute B by 15 units, and substitute C by 14 units. Okay, and we know that S equals to 21 units. So we'll do it now. So the area of triangle ABC equals to the root of S is 21, S 21 minus A is 13 times S minus B. S is 21 minus B is 15 times S is 21 minus C is 14. So in total we got that the area of triangle ABC is this expression. So here 21 minus 13 is 8, 21 minus 15 is 6, and 21 minus 14 is 7. So I write it down. We will get that the area of triangle ABC will be equal to the root of 21 times 8 times 6 times 7. Okay, so the area of triangle ABC is the root of 21 times 8 times 6 times 7. Okay, so the area of triangle ABC will be equal to the root of 21 times 8 times 6 times 7 is the root of 7,056, and the root of 7,056 equals to 84 square units. Okay, so we found out that the area of triangle ABC equals to 84 square units. Okay, in the next step we will define the center of the green triangle as point O. Again, point O is the center of the green circle. Okay, the center of the green circle is point O. Then we will connect together points A and O by a straight line. And then we will connect together points O and B by a straight line. And we will connect together points O and C by a straight line. Actually, we created here three triangles: triangle AOB, triangle BOC, and triangle AOC, and the sum of the areas of those three triangles must be equal to the area of the big triangle ABC, because the big triangle ABC contains those three small triangles. Okay, and we also know that side AB of triangle ABC is tangent to the circle at this point. We will define this point as point D. And then we will draw a radius from the center of the circle, from point O to the launch point, point D. Okay, so this is actually the radius of the green circle that is drawn from the center of the circle to the launch point, that is point D, that is point D is the launch point between side AB of the triangle to the circle. Then we actually, side AC is tangent to the circle at this point. Let's define this point as point E. And then, so point E is the launch point between the tangent AC to the circle. Then we will draw a radius that starts from the center of the circle and touches point E, that is the launch point between the tangent and the circle. Okay, so that is the second radius of the green circle. And then we will draw, actually we have side BC that is tangent to the circle at this point. We will define this point as point F. Point F is the launch point between the tangent BC to the circle. Then we will draw a radius from the center of the circle to point F, that is the launch point between the tangent and the circle. Okay, so that will be the third radius of the green circle. Okay, so we draw three radiuses of the green circle that starts from the center of the circle and touches the launch points between the circle and its tangents. The three radiuses touches the launch point E, F, and D. And we have a rule, I will call it rule number 1. Rule number 1 states that the tangent to the circle is perpendicular to the radius drawn to the launch point. So I read rule number 1 again. Rule number 1 states that the tangent to the circle is perpendicular to the radius drawn to the launch point. So actually we have here three radiuses. This radius is drawn to the launch point. Actually it touches the launch point, that is point D. Therefore, according to rule number 1, this radius is perpendicular to its tangent AB. That is to say, this angle is a right angle and this angle is also a right angle, because the radius is drawn to the launch point, that is point D. Therefore, the tangent is perpendicular to the radius and the radius is perpendicular to the tangent according to rule number 1. And we have also the second radius that is drawn to the launch point, that is to say to point E. Therefore, that radius is perpendicular to its tangent AC. That is to say, this is a right angle and this is also a right angle, because of the fact that the radius is drawn to the launch point, that is point E. Therefore, that radius is perpendicular to its tangent AC, that is to say, that is a right angle, and this is also a right angle, according to rule number 1. And also we have the third radius that is drawn to the launch point, to point F. Actually, it touches the launch point, point F. Therefore, according to rule number 1, this radius is perpendicular to its tangent BC. That is to say, this is a right angle, and also this is a right angle. Okay? So, in the next step, we will calculate the areas of triangle AOB, triangle BOC, and triangle AOC. And we know that the sum of the areas of those three small triangles is equal to the area of the big triangle ABC, because the big triangle ABC contains those three triangles. So the sum of the areas of those three triangles will be equal to the area of the big triangle ABC. So the area of triangle AOB will be equal or before that I will write down the formula that the area of the big triangle AOB equals to the area of the small triangle, the area of the big triangle ABC, the area of the big triangle ABC equals to the area of the small triangle AOB, this triangle, plus the area of the small triangle AOC plus the area of the small triangle BOC. Okay, again, the area of the big triangle ABC, this big triangle ABC, equals to the areas of the three small triangles that triangle ABC contains. That is to say, it is equals to the area of triangle AOB, the small triangle AOB, this triangle, plus the area of triangle AOC, the small triangle, this small triangle AOC, plus the area of triangle BOC, plus the area of this triangle BOC. Okay? So, what is the area of triangle AOB? The area of any triangle equals to the base of the triangle times the height of the triangle divided by 2. So the area of triangle AOB equals to the base of the triangle, that is AB. The base of triangle AOB is AB, times the height. The height is the radius of the green circle, because of the fact that the height must create 90 degrees with the base, and indeed the radius creates 90 degrees with the base AB. Therefore, the radius is the height of triangle AOB. So it is AB times the radius over 2. Okay, so the area of triangle AOB equals to AB times the radius over 2, plus the area of triangle AOB. The area of triangle AOC, the area of this triangle, equals to the base of this triangle, that is AC, times the height. The height of triangle AOC is the radius, because the radius creates 90 degrees with the base AC. So the radius is the height of triangle AOC over 2. So the area of triangle AOC equals to AC times the radius over 2. Again, the area of triangle AOC equals to AC times the radius over 2 plus the area of triangle BOC, that equals to the base of the triangle, that is BC, times the height. The height creates 90 degrees of the base, so the radius creates 90 degrees of the base over 2. So the area of triangle BOC equals to the base of the triangle, that is BC, times the radius over 2. Again, the area of triangle BOC equals to the base of the triangle, that is BC, times the height, that is the radius, over 2. So, and all the sum of the areas of those three triangles, those three small triangles, equals to the area of the big triangle ABC. Equals to the area of the big triangle ABC. Okay? But we know that the area of triangle ABC equals to 84 square units. Okay? So we'll calculate the areas of the small triangles. AB is actually A, that equals to 13 units. So it is A times the radius over 2 plus AC. AC is C, so it is C times the radius over 2 plus BC times the radius over 2. BC is B, so we'll get that is B times the radius over 2. All equals to 84, that is the area of the big triangle ABC. So in total we got that the area of the big triangle ABC, that is 84, equals to the areas of the three small triangles. Here we can take a common factor of R over 2 out of this expression, and in the brackets we will have A plus C plus B equals to 84. Okay, we got that R over 2 times A plus C plus B equals to 84. We know that A equals to 13, B equals to 15, and C equals to 14. So I will write it down. So we got that R over 2 times 13 plus 15 plus 14 equals to 84. 13 plus 15 is 28, and 28 plus 14 is 42. So in total we will get that 42 times the radius over 2 equals to 84 square units. So we got that 48 times the radius over 2 equals to 84. 42 times the radius over 2 equals to 84. 42 over 2 is 21. So in total we will get that 21 times 2, 21 times 21 times the radius equals to 84. 42 over 2 is 21, so in total we got that 21 times the radius equals to 84. Here we can divide this equality by 21 in order to get the value of the radius of the green circle, and 84 over 21 is 4, so we got that the radius of the green circle equals to 4 units. Okay, the radius of the green circle, small r, equals to 4 units. Okay, but we know that the area of any circle equals to pi times the radius squared. The area, the formula for the area of any circle equals to pi times the radius squared, and we know that r equals to 4 units, so we can substitute r by 4 units in this formula, and we will get that the area of the green circle equals to pi times, instead of r we will write 4, because r equals to 4 units, pi times 4 squared, and 4 squared is 16, so the area of the green triangle equals to pi times 16 square units. Okay, so we found out that the area of the green circle equals to 16 pi square units. So in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, so we found out that the area of this green circle equals to 16 pi square units, or the area of the green circle in terms of numbers equals to 50.265 square units. Okay, in the next step I will present the second method to find out the area of the area of triangle ABC. Okay, second method to find the area of triangle ABC. So we will find out the area of triangle ABC according to the law of cosines. Okay, we will use the law of cosines in order to find out the area of triangle ABC. The law of cosines. The law of cosines apply to any triangle. We can use it in any triangle. Okay, so what is the law of cosines? If we have triangle ABC, side AB of this triangle is A. The size of side AB of this triangle is A. The size of side BC of this triangle is B. and the size of side AC of triangle ABC is C, and the angle between A and B is theta, then according to the law of cosine, C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, so this is actually the law of cosines. Okay, C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, so C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, so this is the law of cosines. We can implement the law of cosines in our triangle because of the fact that we know the size of the sides of triangle ABC. We know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. And the only missing variable here is cosinus theta. So we can put the data inside this equality and we will find out the value of cosinus theta, and then we will find out the value of angle theta, and then we will actually draw a perpendicular to side BC of this triangle. That will be the height of triangle ABC. We know that B equals to 15 units, we know that A equals to 13 units, and we know that C equals to 14 units. So actually sinus theta will be equal to H over A, and the only missing variable here will be H, and in this way we will find out the value of the height of triangle ABC, and the area of triangle ABC will be the base of the triangle, that is B. B is known, it equals to 15 units times the height that we have found out, over 2 will be the area of triangle ABC. Okay, so first we will find out the value of cosinus theta according to the law of cosines, according to this equality. Okay, so actually C equals to 14 units. C square is 14 squares. 14 square is 196. Equals to A square. A equals to 13. 13 square is 169. Plus B square. B equals to 15 units. Therefore, B square is 15 square. 15 square is 225. Okay, minus 2 times AB. A times B is 13 times 15. And 13 times 15, 13 times 15 . is 195, and 195 times 2 is 390. Okay, so we got that 196 equals to 169 plus 225 minus 390 cosinus theta. Okay, here we will add 169 to 295, and we will get that 394 minus 390 cosinus theta equals to 196. Here we will add to this equality 390 cosinus theta, 390 cosinus theta, and then we'll subtract 196 equals to 394 minus 196, or 390 cosinus theta equals to 394 minus 196 equals to 198. Okay, so here we will divide this equality by 198, and we will get that cosinus theta equals to 198 over 390. Okay, we got that cosinus theta equals to 198 over 390, and 198 over 390 equals to 0.507692. Okay, okay, it equals to 0.507692. Okay, cosinus theta equals to 0.507692. Okay, we found out the value of cosinus theta. Now we will do the opposite function, the inverse function of cosinus theta, in order to get the value of theta. So arc cosinus theta will be equal to 59.489 degrees. Okay, so theta equals to 59.489,783 degrees. We found out the value of theta. It is about 60 units, 60 degrees. So we know that sinus theta equals to h over a. H over a. Okay, the value of sinus theta is h over a. Okay, and a equals to 13 units. So it is actually h over 13. Okay, so sinus of .59 489,783 equals to, that is the value of sinus theta, 0.86153 equals to h over 13. Okay, that is actually the value of sinus theta. It equals to h over 13. We will multiply this number by 13 and we will get that h equals to 11.2 units. So the height of triangle ABC is 11.2 units. The height h equals to 11.2 units. Okay, we found out that the height of triangle ABC is 11.2 units. So we can write here that the height equals to 11.2 units, and we know that the base is BC equals to 15 units. So the area of triangle ABC will be equal to the base times the height over 2. That is the formula for any triangle, and especially on triangle ABC. It is the base times the height over 2. We know that the base of triangle ABC is B, that equals to 15 units, and the height is 11.2 units over 2. So 15 times 11.2 is 168 over 2. 168 over 2 is 84. So the area of triangle ABC equals to 84 square units. Okay, so we found out that the area of triangle ABC equals to 84 units, 84 square units. Okay, so that was the second method to find out the area of triangle ABC. Okay, and actually after we found out the area of triangle ABC, we will continue in the same way as we did in the first method. We actually created three small triangles, and the height of those three small triangles is the radius of the green circle. And we know that the area of triangle ABC equals to 84 square units. So the area of triangle ABC, that is actually equals to 84 square units, equals to the sum of the areas of these small triangles. That is the area of triangle AOC plus the area of triangle BOC plus the area of triangle AOB. And we know that the area of any small triangle equals to the base of the triangle that is known. The base of this triangle is 13 times the radius that is unknown over 2. The same issue is for the area of triangle AOC, that actually it equals to the base of the triangle that is 14 times the radius that is unknown over 2, and the area of triangle BOC will be equal to B times the radius over 2. So the only missing variable is R, because we know that the sum of the areas of those three triangles equals to the area of triangle ABC, that is 84 units, and the only missing variable that we have here is the radius of the green circle. So we will put the data inside the equality that states that the sum of the areas of those three small triangles equals to 84, and the only missing variable will be only the radius of the green circle, and we will find out the radius of the green circle, and then the area of the circle will be pi times the radius squared. Okay, so I will not repeat on the same process again. In this way we will find out the area of the green circle after we found out the area of triangle ABC. Okay, now I will present you the third way that we can find out the area of triangle ABC. Okay, the third method to find out the area of triangle ABC. Okay, the third method is actually to divide triangle ABC to two right triangles. And in this way, we will prove that the height of triangle ABC is 12 units when the base is 14 units. So the area of triangle ABC will be the base that is 14 times the height that is 12 over 2. 12 over 2 is 6, and 6 times 14 will be equal to 84 square units. So we'll do now all the process step by step, and we actually have this triangle ABC that we can divide to two right triangles. First right triangle, the first right triangle will be So actually, that is the first part of the triangle that we divided to two right triangles. This is a right triangle because 5 square plus 12 square equals to 13 square. Okay, 5 square is 25 plus 12 square is 144, and it equals to 13 square, that is 169. 25 plus 144 equals to 169. That is the proof that this is a right triangle, and you can see that this side is 12 units, and the other part of triangle ABC will be actually this part. Okay, so actually those are the two parts of triangle ABC when I divided it to two right triangles. As you can see, here we have the three sides of triangle ABC. This side is side B of triangle ABC that equals to 15 units. This side is side A of triangle ABC that equals to 13 units. And if we combine the two sides together, 9 plus 5 equals to 14 units, and 14 units is side C of triangle ABC. Triangle ABC composed of three sides that are 14 units, that is side C, 13 units, and 15 units. So if we combine together those two triangles, we will get triangle ABC. In this way, I proved that this is triangle ABC, and the height of triangle ABC when the base is 15 units is 12 units. I will prove also that this is a right triangle because 9 square plus 12 square equals to 15 square. 9 square is 81 plus 12 square is 144 equals to 15 square is 225. You can calculate that 81 plus 144 equals to 225. This is the proof that this is a right triangle. And the big side is in front of the big angle, the biggest angle. Okay, and also here, the big side, the biggest side in this right triangle is in front of the big angle. So this is a right triangle, this is also a right triangle, and if we combine together these two triangles, we will get triangle ABC, because this side, if we combine it together, is 14 units, this side is 13 units, and this side is 15 units. It is exactly triangle ABC. And we know that the area of triangle ABC equals to the base of the triangle, that is 5 plus 9 is 14. The base is equals to 14 units times the height of the triangle is 12 units over 2 is the area of triangle ABC. Okay, actually all the idea here is to prove that the height of triangle ABC is 12 units. When the base of the triangle is 14 units, then the height of triangle ABC equals to 12 units. And in this way, we can calculate the area of triangle ABC that equals to the base of the triangle that is 14 units times the height of the triangle that is 12 units over 2. So the area of triangle ABC equals to 14, that is the base of the triangle, times the height that is 12 units over 2. And 12 over 2 is 6. So we will get that the area of triangle ABC equals to 14 times 6, and 14 times 6 is 84, so the area of triangle ABC equals to 84 square units. Okay, the area of triangle ABC, as we calculated it in the third way, equals to 84 square units. And again, after we found out the area of triangle ABC, we will divide triangle ABC to 3 triangles, triangle AOB, triangle BOC, and triangle AOC. And we know that the radius is the height of the 3 triangles, and the area of the 3 small triangles equals to the area of the big triangle, of the sum of the areas of the 3 small triangles equals to the area of the big triangle ABC, that equals to 84 units. And the only missing variable that we have here is the radius, and we know that the sum of the areas of the 3 triangles, the small 3 triangles, equals to 84 units. And the only missing variable is the radius, and so we will find out from the equality that states that the area of the sum of the areas of the 3 triangles, the 3 small triangles, equals to 84. And the only missing variable is the radius, because we know that the base here is 13, the base here is 15, as the base of the triangle is 14, and the base times the height, that is the radius, over 2 equals to the area. So the only missing variable is the radius, because we know that the sum of the areas of those 3 small triangles equals to 84, and the only missing variable here is the radius. So we will solve this equality that states that the area of the sum of the areas of the 3 small triangles equals to 84 square units. And we will find out that the radius, that is the only missing variable in this equality, equals to 4 units, and then we will square the radius and we will multiply it by pi, and we will find out that the area of the green circle equals to 16 pi, or 50.265 square units. Okay? So I will not repeat on the same process again. It is exactly the same process to find out the area of the green circle as we did in the first way. Okay? In the next step, I will present a second way to find out the radius of the green circle when we already know the area of the triangle. Okay, because we know that the area of triangle ABC equals to 84 square units, and we will use this data in order to find out the radius of the green circle. Okay, so in the next step I will present the second method to find the radius of the green circle. The first method was as I already told you just a minute ago, is to divide the triangle ABC to three small triangles and to create the equality that states that the sum of those three small triangles equals to 84, and the only missing variable here is the radius. We will solve this equality and we will find out that the radius equals to 4 units. And then we will multiply, we'll square the radius and we will multiply it by pi in order to find out the area of the green triangle. Okay, so that is the first method to find the radius of the green circle, and now I will present you the second method to find out the radius of the green circle. Okay, so actually I present a formula that is right in any circle that is inscribed inside a triangle we have the following formula to find out the radius of the circle that is inscribed inside the triangle. The radius will be equal to the area of the triangle that contains the circle divided by the semi-perimeter of the triangle. And I have already explained you that S, that is the semi-perimeter of the triangle, equals to the sum of the sides of the triangle, that in this case it is actually A plus B plus C over 2, and we actually found out that it is actually equals to 21, because it is actually 13 plus 15 plus 14 over 2. It is actually equals to 21 units, and we have already found out that the area of the green triangle ABC equals to 84 square units. So actually the radius of the green circle equals to the area of triangle ABC over S. The area of triangle ABC is 84 square units over S, that is the semi-perimeter of triangle ABC, that is 21. So 84 over 21 is 4 units. So the area, the radius of the green circle equals to 4 units. And the area of the formula for the area of any circle is pi times the radius of the circle squared. And we know that R equals to 4 units, so we'll substitute R by 4, and we will get that the area of the green circle equals to pi times 4 squared, that is actually equals to 16 times pi square units of the area of the green circle in terms of numbers is 50.265 square units. Okay, so we found out that the radius of the circle is 4 units, and the area of triangle, the green triangle, the area of the green circle equals to 16 pi, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, so the area of this green circle equals to 50.265 square units, or 16 times pi square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green circle. This green circle is inscribed inside triangle ABC, and we know that side AB that equals to 13 units is tangent to the circle at point D. Okay, and we also know that side BC of triangle ABC is tangent to the green circle at point F, and we know that side AC of triangle ABC is tangent to the circle at point E. So actually points D, E, and F are the launch points between the triangle and the circle, or are the launch point between the triangle, the launch points between the circle and its three tangents. Okay? Okay, so in the first method, we found the area of triangle ABC according to the formula that the semi-perimeter of any triangle equals to the sum of the three sides of the triangle over 2. So the semi-perimeter of triangle ABC equals to A plus B plus C over 2. Okay, the semi-perimeter of triangle ABC equals to A plus B plus C over 2. That is the perimeter of triangle ABC divided by 2. And we defined the letter S as the semi-perimeter of the triangle, and found out that S equals to A plus B plus C over 2. A is 13, B is 15, and C is 14. So 15 plus 13 plus 15 plus 14 over 2 is 42 over 2, and we found out that 42 over 2 is 21. So we found out that the semi-perimeter of triangle ABC equals to 21 units. Okay, and then we have a special formula for the area of triangle ABC. It is the formula for any triangle, that we know the semi-perimeter of it, and we know the value of the sides of this triangle. We can calculate the area of the triangle according to this formula. So the area of triangle ABC according to the formula, this formula equals to the root of S. S is the semi-perimeter of triangle ABC that we have already found out that is equals to 21 units, times S minus A equals to 13 units, times S minus B equals to 14 units, times S, that is 21, minus C, that equals to 14 units. Okay, we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units, and S equals to 21 units. So we have all the data, and the only thing that is left is to put the data inside this equation for the area of triangle ABC. So we put the data inside this equation, and we found out that the area of triangle ABC equals to 84 square units. Okay, and in the next step, so we know that the area of triangle ABC equals to 84 square units, and the question is to find out the radius of the green circle. So in order to find out the radius of the green circle, we divided triangle ABC to 3 small triangles. The first triangle is triangle AOB, the second triangle is triangle AOC, and the third triangle is triangle BOC. And we know that the sum of the areas of those three small triangles equals to the area of the big triangle ABC. And we know that the area of triangle ABC equals to 84 units. Okay, and in the next step, we drew 3 radiuses that starts from the center of the circle and touches the points, the launch points between the circle and its tangent. Point D, point E, and point F are the launch points between the circle and its tangents. Okay? And we have a rule, I call it rule number 1. Rule number 1 states that the tangent to the circle is perpendicular to the radius that is drawn to the launch points. Okay, so actually this radius exits from the center of the circle, this is point O, and touches the circle at point D, that is the launch point between the tangent and the circle. So the radius is drawn to the launch point, that is point D. Actually it touches point D. Therefore this radius is perpendicular to its tangent AB, that is to say this is a right angle and also this is a right angle. Okay, so the radius is perpendicular to side AB, that is the tangent to the circle. And also the second radius that we draw from the center of the circle, exits from the center of the circle and touches the circle at point E, that is the launch point between the tangent AC to the circle. So this radius is drawn to the launch point and it touches to the launch point. Therefore, according to rule number 1, this angle is a right angle and this angle is also a right angle because the radius is perpendicular to its tangent AC. When the radius is drawn to the launch point, the radius will be perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. And we have the third radius that is drawn to the launch point. That is to say, this radius is drawn to point F, that is the launch point. Therefore, this radius is perpendicular to its tangent BC. That is to say, this angle is a right angle. And also this angle is a right angle. Because the radius is perpendicular to its tangent. When the radius is drawn to the tangent, is drawn to the launch point, that is point F, then the radius will be perpendicular to the tangent BC, that is to say this angle is 90 degrees and this angle is also 90 degrees because the radius is drawn to the launch point. Therefore, the radius will be perpendicular to its tangent BC. That is to say this angle is 90 degrees and this angle is also 90 degrees. Okay, and we calculated the areas of the 3 small triangles, and the sum of the areas of these 3 small triangles equals to the area of the big triangle ABC. okay, that is equal to 84 square units. So what is the area of triangle, the small triangle AOB? It equals to the base of the triangle, that is A, that equals to 13 units, times the height, that is the radius. The radius must, and the height must create 90 degrees with the base. So this radius creates 90 degrees with the base. Therefore, the radius is the height of triangle AOB. So it is the area of triangle AOB is the base, that is A, times the height, that is the radius, over 2. So the area of triangle AOB equals to AB times the radius over 2, and the area of triangle AOC equals to the base of the triangle, that is C, times the height, that is the radius, over 2, and the area of triangle BOC equals to the base of the triangle, that is B, times the height, that is the radius, over 2. Okay, so, and we know that the sum of the areas of the three small triangles equals to the area of triangle ABC, that is 84 square units. Okay, and we know that AB actually it equals to A, that is 13 units, and AC that equals to C equals to 14 units, and BC, that is B, equals to 15 units. So we know all the values of all the variables here. The only missing variable that we have here is the radius of the green circle, because we know that the sum of those three triangles equals to 84 square units. And the only missing variable that we have here is the radius of the green circle. Okay, so we put the data inside this equality, and we found out that the radius of the green circle equals to 4 units. The radius equals to 4 units, so the area of any triangle is pi times r square, pi times the radius square, and we have already found out that the radius of the green circle equals to 4 units, so we can substitute r by 4 because r equals to 4 units, and we got that the area of the green circle equals to pi times 4 square, that is 16, or the area of the green circle equals to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, and then we found out the area of the this green triangle ABC in the second method, according to the law of cosines. C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, so the law of cosines states that C square equals to A square plus B square minus 2 times AB times cosinus theta. Here C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, so we can implement the law of cosines in our triangle ABC, because we know that this side A equals to 13 units, this side C equals to 15 units, and this side equals to B, that is 15 units. So we have all the variables inside this equality. The only missing variable here is cosinus theta, because we know all the sides of A, B, and C. A equals to 13 units, B equals to 15 units, and C equals to 14 units. And the only missing variable is cosinus theta, so we put the data inside this equality, and we found out that cosinus theta equals to 0.507692, and Then we did the opposite function, we operated the opposite function of cosinus theta in order to find out the value of theta, because we know that cosinus theta equals to 0.507692, and in order to find out the value of theta, we operated the inverse function of cosinus theta, and we found out that theta equals to 59.489783 degrees. So then when we found out the value of theta, we found out that the value of theta is 59.5 degrees, more or less. So sinus theta equals to h over a. Okay, theta equals to 59.5 degrees, more or less. So sinus theta will be equal to h over a. And okay, sinus theta equals to h over a, and the only missing variable here is h, because we found out that sinus theta equals to this number. So sinus theta equals to h over a. We know that a equals to 13. The only missing variable here is h. And we put the data inside this equality, and we found out that h equals to 11.2 units. Okay, so we actually found out the height of triangle ABC. It is equals to 11.2 units. So the area of triangle ABC will be equal to the base of the triangle, that is B, that equals to 15 units, times the height of triangle ABC, that is H, that equals to 11.2 units, over 2. Okay, so the area of triangle ABC equals to the base of the triangle times the height over 2. The base is 15 units, the height is 11.2 units, all divided by 2. So we put the data inside this equality, and we found out that the area of triangle ABC equals to 84 square units. Okay, so this was actually the second method to find out the area of triangle ABC. And then I presented third method to find out the area of triangle ABC. Actually, we divided this triangle ABC to two right triangles. We proved that this is a right triangle because it obeys to the Pythagorean theorem, because 5 square plus 12 square equals to 13 square. And we also proved that this is a right triangle because 12 square plus 9 square equals to 15 square. So we divided triangle ABC to two right triangles, and by dividing triangle ABC to two right triangles, we actually proved that if the base of triangle ABC is equals to 14 units, 9 plus 5 is 14 units, then the height must be equal to 12 units. Okay? And in this way we can find out the area of triangle ABC that equals to the base of the triangle times the height of the triangle over 2. Okay, so the area of triangle ABC in the third method is the base of the triangle that is 14. 14 is 5 plus 9 times the height that is 12 units over 2. Okay, so actually in this way we proved that if the base is 14 units, then the height must be equal to 12 units, and we proved that the area of triangle ABC equals to the base of the triangle that is 14 units, and the height must be equal to 12 units over 2. So 14 times 12 over 2 is 6, and 14 times 6 is actually equals to 84 square units. So in this way we found out the area of triangle ABC in the third way. Okay, and then we found out the radius of the green circle in the second way. In the first way we found the radius of the green circle by dividing triangle ABC to 3 small triangles, and after we divided triangle ABC to 3 small triangles, triangle AOB, triangle POC, and triangle AOC, we created the equality that states that the area of triangle ABC, big triangle ABC, equals to the sum of the areas of the 3 small triangles. And we have already found out that the area of triangle ABC equals to 84 units. And so here we have the only variable that is missing is the radius of the small circle. So we put the data inside this equality that the sum of the areas of the 3 small triangles equals to 84 units, and in this way we found out the value of the radius of the circle, and the area of the circle will be equal to pi times the radius squared. So we squared the radius, we multiplied it by pi, and we found out the area of the green circle. Now I presented the second way to find out the radius of the green circle. Actually, in any circle that is inscribed inside the triangle, we have this formula to find out the radius of the circle that is inscribed inside the triangle. The radius of the circle that is inscribed inside a triangle will be equal to the area of the triangle that contains the circle divided by the semi-perimeter of the triangle that is inscribed that contains the circle. And the semi-perimeter of any triangle equals to the perimeter of the triangle divided by 2. Okay, and we have already found out that the area of triangle ABC equals to 84 square units, and we found that the semi-perimeter of triangle ABC, it is actually 21 units. So we divided the area of triangle ABC that is 84 square units by the semi-perimeter of triangle ABC that is 21 units, and we found out that the radius of the circle, of the radius of the green circle equals to 4 units. Okay, and the formula for the area of any circle is pi times the radius of the circle squared, and we know that r equals to 4 units. So we can substitute r by 4 units. We substituted r by 4 and we got that the r of triangle ABC equals to pi times 4 square. That is actually 16 pi square units. So the area of the green circle equals to 16 times pi square units. So in terms of numbers, the area of the green circle equals to 50.265 square units. Again, the area of this green circle equals to 50.265 square units, or to 16 times pi square units. Okay, thank you very much.